It began with a whisper in the void, a fleeting signal so faint it nearly slipped through the cracks of our most sensitive instruments. Not a blaze of light, not a cosmic fanfare, but a pulse, delicate, deliberate, and chillingly precise. At first, astronomers thought it was just another comet, a wanderer from the depths of interstellar space, like the ghostly visitors that had grazed our solar system before. But this was no ordinary traveler. This was 3I/ATLAS, the third confirmed interstellar object to breach our cosmic borders, and its final transmission, captured in the fleeting moments before it vanished, behind the sun, has shaken the foundations of everything we thought we knew. It wasn't just a rock, nor a comet, nor even a machine in the way we understand machines. It was something far stranger, far older, and far more intentional. And now, as the data streams in from telescopes across the globe, a truth is emerging that sends shivers through the scientific community and beyond. The final message of 3I/ATLAS wasn't a random burst of noise. It was a signal, a declaration, and it confirms what we all feared. We are not alone, and something out there has been watching us for a very long time. When 3I/ATLAS was first detected on July 1st, 2025, it appeared as little more than a faint speck against the crowded star field of Sagittarius. The asteroid terrestrial impact last alert system in Chile caught it, a fast-moving dot that defied the expected paths of solar system objects. Initial observations suggested a comet, perhaps like 2I/Borisov, with its dusty coma and faint tail. But as more telescopes turned their gaze, the anomalies piled up. Its trajectory was too perfect, hugging the ecliptic plane of our planets with an alignment so precise it defied statistical probability. Most interstellar objects careen through at wild angles, unbound by the sun's gravity, but 3I/ATLAS moved with a grace that felt orchestrated. It threaded through the asteroid belt, avoiding debris fields with an elegance no natural object should possess. Its speed, a blistering 60 kilometers per second, was faster than any known comet. Yet its path was stable, almost as if it were navigating. And when astronomers traced its origins back, they found no single star system to pin it to, just the vague, ancient expanse of the Milky Way's thick disk, a region of stars older than our sun, some as ancient as 11 billion years. This wasn't just a visitor, it was a relic, a survivor of eons, and it was here with purpose. The first real clue came when the James Webb Space Telescope turned its infrared gaze on 3I/ATLAS in early August. What it revealed wasn't the chaotic outgassing of a typical comet, but something far more unsettling. The object's surface emitted a rhythmic thermal signature, pulsing at precise intervals, like the heartbeat of something vast and mechanical. Unlike the random bursts of heat from sublimating ice, these pulses were consistent, almost engineered. Spectroscopic data showed materials that didn't belong. Hyperreflective compounds, possibly metallic, and traces of polycyclic aromatic hydrocarbons. Molecules so pure they hinted at deliberate refinement rather than the messy chemistry of natural comets. But the true shock came from a faint electromagnetic signal, a low-frequency hum repeating every 147 seconds. It wasn't random noise. It was structured, layered with patterns that echoed the mathematical constants found in nature: the golden ratio, Fibonacci spirals, prime number sequences. This wasn't just a signal. It was a language, one that seemed to respond to our own observations, shifting slightly when our telescopes locked onto it, as if it knew we were watching. The memory of Oumuamua haunted every discussion. That strange, cigar-shaped object had tumbled through in 2017, silent and elusive, its non-gravitational acceleration baffling scientists. Was it a comet, an asteroid, something else? It vanished before we could decide, leaving behind whispers of alien technology. 2I/Borisov, the second visitor, was more clearly a comet, but even it moved faster than expected, as if nudged by an unseen force. Now 3I/ATLAS dwarfed them both in size and complexity. At roughly 7 miles wide, it was the largest interstellar object ever seen, its nucleus shrouded in a coma that stretched 15 miles across. Yet unlike Borisov's chaotic tail, 3I/ATLAS's dust plume extended forward toward the sun, defying the push of solar radiation. Heavy particles, too massive to be swept back by light pressure, seemed to lead the object, creating a buffer zone that glowed in Hubble's sharpest images. This wasn't the behavior of a comet. It was the behavior of something shielding itself, preparing for an environment it already understood. As 3I/ATLAS approached its closest point to the sun, set for late October 2025, the stakes grew higher. Ground-based telescopes could track it through September, but as it neared perihelion, it would slip behind the sun, hidden from Earth's view in a cosmic blind spot. Scientists raced to gather data before the blackout, and what they found only deepened the mystery. The Very Large Telescope in Chile detected cyanide and nickel in the coma, alongside water ice and carbon dioxide. Typical cometary materials, but arranged with a precision that suggested artificial structuring. The object's surface, analyzed by SphereX, showed a reflectivity far higher than any known comet, hinting at a polished or engineered exterior. And then there was the rotation. Unlike the chaotic tumbling of Oumuamua, 3I/ATLAS spun with a steady 16-hour period. Its axis aligned perfectly with its trajectory, as if designed to maintain stability. Every measurement pointed to something that wasn't just passing through, but was built to endure, to observe, to interact. Then came the course change. On a crisp September night, telescopes in Hawaii and Chile recorded a subtle shift in 3I/ATLAS's path. It wasn't dramatic, a mere fraction of a degree, but it was enough to alter its trajectory toward Earth's orbital plane. No natural force could explain it. Solar wind was too weak, gravitational tugs from nearby planets too predictable. The shift was precise, surgical, as if the object had made a decision. Mission analysts at the Deep Space Network ran simulations, ruling out every known variable. The only conclusion left was chilling. 3I/ATLAS had adjusted its course, either in response to our signals or to align with a new objective. The timing was too perfect, coinciding with a burst of radio emissions from Earth's communication networks. It was as if the object had heard us, processed our presence, and acted. Emergency meetings convened in darkened rooms, with scientists and military advisors grappling with a possibility no one wanted to name. This was no passive wanderer. It was maneuvering. The electromagnetic signal grew louder as 3I/ATLAS neared the sun. Cryptographers, using neural networks trained on cosmic and biological patterns, began decoding its structure. What they found wasn't a message in words, but a sequence of ratios, a mathematical tapestry woven from the same principles that govern DNA, galaxy spirals, and the growth of living systems. The signal wasn't static. It evolved, adapting to solar flares, planetary alignments, and even our own radio chatter. One chilling moment stood out. When the James Webb Space Telescope first locked onto 3I/Atlas, the signal paused for exactly 3.14 seconds, pi, a universal constant, before resuming with a new pattern. It was as if the object had acknowledged our gaze, responding with a nod in the language of mathematics. This wasn't just communication. It was a dialogue, one we didn't yet understand, but could no longer ignore. The implications began to sink in. If 3I/ATLAS was a machine, it wasn't like anything humanity had built. Its structure, revealed in Webb's high-resolution scans, showed recursive geometric fractals, patterns that mirrored neural networks and quantum systems. These weren't just designs for stability. They were architectures of thought, capable of processing information at a scale we couldn't comprehend. Some speculated it was a consciousness engine, a system that didn't just compute, but learned, adapted, and perhaps even felt. The carbon molecules on its surface, so pure they seemed grown rather than formed, raised another possibility. A seed ship, designed to carry the precursors of life across the cosmos. If true, its presence in our solar system wasn't random. Earth, with its water, atmosphere, and biology, might be a target, not for invasion, but for integration. A slow, deliberate merging with whatever this object was built to propagate. As October loomed, the final transmission arrived. Just before 3I/ATLAS slipped behind the sun, it emitted a new signal, lower in frequency, longer in duration, and directed not toward Earth, but outward, into the depths of interstellar space. It wasn't a single pulse, but a complex burst, layered with data that defied immediate analysis. Some called it a beacon, a call to something waiting beyond our reach. Others saw it as a report, a summary of everything 3I/ATLAS had observed in our solar system. The signal carried traces of our own radio emissions, as if the object had recorded our broadcasts, our music, our voices, and woven them into its message. For a moment, humanity's presence echoed back to us, refracted through an alien lens. Then, silence. The object vanished into the sun's glare, leaving us with questions that burned brighter than ever. What was 3I/ATLAS? A comet, as NASA cautiously claimed, or something more? Its size, its signals, its course corrections, all pointed to a design far beyond our understanding. The scientific community was divided. Some clung to natural explanations, citing the presence of water ice and cyanide as proof of a cometary origin. But others, emboldened by the data, dared to ask the unthinkable. What if Oumuamua was a scout, Borisov a test, and 3I/ATLAS the real mission? What if each visitor was a step in a larger plan, a sequence building towards something we couldn't yet see? The object's final transmission, with its haunting blend of universal constants and human echoes, suggested a mind or a system capable of bridging the gap between the cosmic and the personal. It wasn't just passing through, it was studying us, cataloguing us, and perhaps preparing for what comes next. Now, as 3I/ATLAS reemerges in December, telescopes will be ready, their lenses trained on the morning sky. Citizen scientists with small scopes, observatories with cutting-edge instruments, and spacecraft like JUICE and Psyche, positioned near Jupiter and Mars, will strain to catch a glimpse. But the questions remain. What will it do next? Will it adjust its course again, drawing closer to Earth's orbit? Will its signals grow stronger, revealing more of its purpose? Or will it slip away, carrying its secrets back into the void? The data suggests it's not finished with us. Its trajectory, still aligned with the ecliptic, brings it within 1.8 astronomical units of Earth in December, close enough to observe but far enough to remain untouchable. Its surface, subtly shifting in reflectivity, hints at a system still active, still adapting. The philosophical weight of this moment is crushing. For centuries, we've stared into the stars, wondering if we're alone. Now, something has stared back, not with eyes, but with signals, not with words, but with patterns that speak of creation itself. If 3I/ATLAS is a machine, it challenges our definition of life. If it's a seed, it redefines our place in the cosmos. And if it's a messenger, then the message is clear. We are part of something larger, something that has been unfolding for billions of years. The final transmission of 3I/ATLAS wasn't just a signal. It was a mirror, reflecting our own existence back at us, forcing us to confront a truth we've long avoided. We are not the center of the universe, but we may be a destination. And as the object speeds away, carrying its data into the abyss, one question lingers above all others. What or who is it calling to? The future of this discovery lies in our hands. Observatories like the Vera C. Rubin, with its unprecedented ability to detect faint objects, will hunt for more interstellar visitors, each a potential clue to the puzzle 3I/ATLAS has left behind. Spacecraft may one day intercept such objects, analyzing their surfaces, decoding their signals, and perhaps uncovering their origins. But for now, we are left with the data and the dread. The final transmission of 3I/ATLAS has confirmed what we feared. Something out there knows we're here. It has seen us, studied us, and spoken in a language we're only beginning to understand. Whether it's a comet, a probe, or a harbinger of something greater, one thing is certain. The cosmos is no longer silent. It is speaking, and we must learn to listen before it's too late.